Good morning, everyone, and thank you very much for joining this webinar, which is co-hosted by PAVE Europe and SYNERGIES. SYNERGIES is an EU project funded by the European Union that started a year and a half ago. And the main goal of SYNERGIES is to create European framework-based safety scenario based on real-world cases. And the speakers we have today will tell you more about the project, but just to introduce you how the webinar will work. So it will last 60 minutes. We encourage you to ask your questions in the chat. So you can use the chat at the bottom right of the Zoom webinar. And I will also encourage you to answer some questions that we have for you because we want to keep the webinar as dynamic as possible. So I wanted to first thank also the speakers we have today. So we have Adrian Zlocki from FKA, Clément from CEESAR, Fadi Alakkad from University of Warwick, who will show us the crowdsourcing platform that has been developed in the framework of the project. Riccardo Donà from JRC, European Commission. And last but not least, we have Luciana Iorio, who is also our keynote speaker. So I welcome her and ask her to start with her presentation. Thank you very much.
Thank you. Thank you, Mrs. Frigerio. Good morning to the colleagues and good morning, everyone. Now, if you bear with me, I will just do the trick and hopefully it will work. If it's not, that one. Okay, so, yes, okay. Have we tuned in? That's good. You know, the first thing with the tech things is just make that your tech things are going to work. So that's the good point. Thank you to all the distinguished speakers and thank you to the PAVE Europe webinar organizer. And of course, I will start clicking, but this is just the disclaimer, which is useful only for offices reason. But this is the good point and are my praises and accolades for PAVE Europe and their incredible achievements, as well as the CCAM SYNERGIES project, which is a EU project. And I just want to, before I start my approach, is just that I just wanted to praise this research effort. They are of incommensurable value and the worthiness is incredible because the situation about, let's say, connected and cooperative vehicles, automated vehicles, is still very, very complex. And because I'm a keynote speaker, I am not addressing the project's outputs or achievements, but I'm just throwing on the floor even more questions that you had before. But I'm sure that the researchers know the solution. So here we are. I am speaking as a UNECE Global Forum for Road Traffic Safety chairperson. And you know that Global Forum, or WP1 in the UN jargon, plays a crucial role in shaping the mobility and the traffic of the present and future, because it has in its mandate two conventions, one on road traffic and the other one on road sign and signals. And so we have with other working party you may be familiar with, such as the vehicle regulation, aka called, let's say, the WP29, how to safely, how to deploy the AV in a safe and harmonized ways across the countries. That is not such an easy task, hence this is why research is so very relevant. But here we are. So the big point on what we are discussing and discussing, and many times we are just looping around, is that we know that we don't know so many things, you know, so bear this in mind. So there are still many technical and operational challenges. And needless to say, I will not dwell in that, but you can immediately imagine how complex the traffic environment is and how these vehicles, which could be, let's say, whose performance is going to be, let's say, has to be perfect, even though human drivers are not perfect, but we do expect perfection from these vehicles. So there are still a lot of technical and operational challenges, you know better than that, and we work closely with the WP29 colleagues. In our mandate, there is the big issue of responsibility and liability, which, you know, is something which is assessed to date, but is not assessed in the bigger framework when you move from a human to a system, you know, and hence also the ethical decision making, you know, where the moral compacts of a system will shift. That is another big question we have on the table. And then the big issue of what are we going to do with human drivers? You know, I mean, are these vehicles going to be the same everywhere in the world? Do they will follow the local traffic rules? And how could we reach harmonization? So this is the big question we do not know. So here we are another, let's say you could see that is a funny slide, just to, let's say, stimulate and keep you, let's say, alert for the following very technical distinguished speakers from SYNERGIES. We are auditing for new actors. Every time I have a session at the Global Forum, I hear a new actor on the stage. You know, we had the traditional driver. Now we have the driver who could perform other activities when the system is engaged. So you have the actor, I will call actor quoted, actor on and off, driver on and off. So he's a driver, but he could do other things. And then he can, let's say, retake the control. By the way, this is a very, let's say, dangerous point because, you know, on one hand, we are, let's say, following the non-distraction driver. So policies about distraction. On the other way, we are suggesting that when the system is engaged, you can take your eyes off the road. So it's a very complex, very, how can I say, very edgy situation. Then I heard also about a user in charge, because of course, if the system is driving, you are not the driver anymore, but you are called the user in charge. Then I heard someone talking about operators, you know, because of course, if you are a remote, not in the car, you can also be a remote controller. Others speak about agent. Now, why I am, let's say, using this, let's say, different perspective. I will tell you a bad news. None of these definition is in the convention, unless it's a driver, you know? So if we are going to use any of these expression or whatever comes up in your mind during the night or after a good drink, you know, user in charge, operators, agent from the moon, from the planets, you know, beyond the Orion belt, whatever, has to be in the convention in order to be legal. That's the big point. So are we thinking of a new mobility? What is our timeline? 200, let's say 2100? Is that it? So, okay, you are maybe in the audience, you are very young, you don't remember, you know, Back to the Future, when there is a famous quip when they are driving these incredible cars, and actually he's still driving, you know, and says, we don't need roads. Then I hear also colleagues saying, oh, what are we ruling AV? We will have a flying taxi. So how are we going to talk about flying taxi? What are they? Are they vehicles? Do they respond to road traffic or to let's say, flight regulation? You know, but anyway, this is one of the fantastic slides I have picked up. But again, I'm saying that not because, you know, say, oh God, which kind of presentation are we witnessing? In order to foster your thoughts. So if the mobility we are envisaging is a completely automated one with also objects which are not vehicles by the conventions, but maybe will be in a future, the other question is linked to the big green planet you will see there. And why is that? because at the same time, we are claiming to have a sustainable agenda. But the traffic we have in mind is not going to be sustainable from as far as energy is concerned. If we think that we can sustain the traffic we have now, transformed in autonomous automated traffic, you know, you will need, let's say, a sort of a hunger data devourer, you know, is just going to have, is just a system which is going to need a lot of energy. So let's think about that. How do we really aim at? And then last slide, so I will make the organizer happy because I'm just staying in the timing. And so what are we really aiming at? What do we really want? This is a question that we work and we have on the Global Forum desk, and we work together with other colleagues. And so the big problem is attractiveness. I mean, is the world really waiting for this AV? Are we sure? I mean, let's look at the demography, how the planet is going to be in 40 years, in 30 years. Maybe the young generation, the future generation, they're not interested in any vehicles at all. They just want public transport. They just would like, I don't know, hyperlooping here and there, you know. So are we sure that the effort is worthy the pain? Public acceptance. If you go around, is the public really ready to become a sort of a pilot? I mean, we need to work on that, you know, and the same of the AV capacity of assuming responsibility and being a decision-making, not to speak about regulatory impact, you know, that is a nightmare. Harmonization and non-harmonization, you know, Eurocentric people are very good on regulation. I am, you know, I mean, I want the rules very, very well clear. Other regions of the world, they say that if you are ruling too much, you are stopping the future. You will not announce, you know, the future going ahead. You will not allow future going ahead. So this is something debatable. And then the costs, you know, how much is going to cost all this effort? Back again, is really what we want? Is really worth the effort? And then we have all these wishes and whispers. It will be good in order to enhance safety. It will lessen the traffic burden. It will enhance the livability and the mobility. But these are wishes in the bucket. We don't know yet, you know. Hence the big efforts of the research. We are really happy to, let's say, wait and looking forward the results of the colleague from PAVE Europe, PAVE Global PAVE, and the SYNERGIES as one of the many projects working on that. And thank you kindly, I mean, for having me, let's say, prompting all these questions. I leave the floor now to other colleagues which will walk you through a proper research pattern. But bear this in mind. Thank you so much.
Thank you so much, Luciana. And thank you so much for the last slide that mentioned trust. We have actually a question for our audience because we would like to hear from them how much they trust vehicles. And maybe on these last point, I would like to ask you if you can very quickly name one ingredient that, from the Global Forum's perspective, you think is crucial for building trust in CCAM systems.
Yeah. Yes, thank you for this question. For what we have been talking at the Global Forum and discussing at Global Forum, also with the behavioral psychologists and engineer colleagues and so on, what would build the trust is to assess and witness AV deployment in real traffic. You know, that could be one issue. So case studies, appropriate scenarios are very well welcome, because until I am told that this is working in a desert, or this is working in a, let's say, a specific research scenario or scenario site or a research site, that is, I mean, so far so good. I want to see that really working in a real city and welcome by road users, all road users. Because I have, for example, I heard from the Association of Pedestrians, they are wary of that. You know, I heard that the bikers association are really wary of that, you know. So, but I'm sure I really rely on research and future, because I am sure that the technology will enhance mobility. So my presentation was just to prove how, let's say, complex is the work, but also that we will get results. Thank you.
Thank you very much. And talking about research, I would like to move on now to Clément, who is joining us from CEESAR, and he will guide us through, with his presentation, he will guide us through how scenarios are actually important for safety. Since Luciana, you mentioned also cities and how safety is important in these settings. So thank you, Clément. Perfect.
Do you hear me?
Yes.
Does the audio work? Not sure.
Yes, we can hear you.
Perfect. Yeah. Thank you. So yes, you said it was a scientific perspective, but I won't speak about much science, at least not in detail, but I try to emphasize what the scientific challenges are when we try to validate the safety of automated driving systems. So the question was, okay. The question was, how do data and scenario contribute to a safer automated mobility? So first, I tried to define what a safer automated mobility would be, what kind of criteria we are speaking about. Should we aim at something that is as safe or safer than a human driver? I guess that's the aim. But if we want to ensure that, we need to be able to demonstrate it. And if we want to demonstrate it, we need evidence. So of course, evidence is some form of data. We need data that proves that those vehicles are sufficiently safe. So how can we approach that? Can we, well, just drive around and count crashes? It should be feasible statistically to demonstrate that we have the same amount or less crashes with automated driving systems than with human drivers. The problem is, or let's say problem, it's not really a problem, but serious crashes are rare, luckily. If we speak about fatal accidents, it's only a few each billion of kilometers traveled by a vehicle in Europe, around 5 on average. So we would have to do billions and billions of kilometers to really demonstrate that those automated driving systems are safer than human drivers. So it's not realistic to do that, to just demonstrate that something that we are going to introduce on the road is sufficiently safe. And even if we drive billions of kilometers, we can ensure that those kilometers that we have driven are the right one, that they are challenging, if we don't select them carefully. So we can't ensure that we are going to meet the problematic situation. And on a side note, maybe it's something that we can do once we are pretty sure that those systems are sufficiently safe to be on the road, and we can confirm that in a few years. But at the early stage of development or early stage of deployment, nobody wants to have very rough prototypes driving around in their neighborhood unsupervised. So an additional issue beyond the fact that we need to demonstrate over the equivalent of billions of kilometers is that we need to do it repeatedly. Of course, while we develop a system, we need to be able to redo the validation, because if we see during verification and validation that there is a problem and we try to correct it, we need to verify that we have corrected it, but that there was no regression when we corrected it. So we need to be able to do repeated validation during the development. But even on production, all the things that we observe, they depend on the hardware and they depend on the software. And the hardware will change from one vehicle to the next, even the same vehicle model. From 1 year to the next, the hardware may change. And nowadays, the software can change all the time with software update over the air. So again, we need repeated validation, verification, and validation, which means that we need to be able to capitalize what we learn, to be able to use this knowledge to be able to do a repetition of different kind of validations. A solution can be to approach this issue with a multi-pillar approach, so to use different methods to validate the system, and methods that are complementary with each other. Some of them are able to scale at a large scale. Some of them are 100% repeatable. Other are more realistic. So we need to combine different approaches to be able to ensure as much as possible that we capture everything. Those methods for validation and verification, they are trying to run a model of your system in the loop in a simulated environment, in everything in software, everything in a computer, trying to run your actual software, again, in a computer in a simulated environment, maybe to run part of your hardware in a simulated environment, and then on some specific scenarios to demonstrate that your actual physical product, your vehicle, is safe on select cases, on carefully selected cases. And then, of course, you need to, at some point, to drive it on the public roads, to have the reality and to do it on the right environment to make sure that you observe and that you learn new things and that you are able to identify problems that you had not thought about when you were working in the abstract. And to be able to do all those things, we need a way to define what we are going to test and to define in which circumstances we are going to test things. So to define the circumstances in terms of driving scenario, of driving situation, that's what we call scenarios. So the scenarios, they are a common language, a way to unify for all the way that we will use it for validation, to have a single way to describe what we're going to simulate or to observe. And of course, we can use it for the specification phase as well. If we are able to define scenarios, we're able to say in which way our system should be able to react in specific situations. And the question then is, how do we create those scenarios? How do we describe those driving situations that are going to be used during verification and validation? So of course, when we do so on the left, when we do some tests with prototypes or with, let's say, early vehicles in controlled environments, but on the open road, we will learn things, and this should be capitalized as scenarios. But we can also use sheer simple knowledge from the past. We have learned a lot of things, and we can say this kind of thing can happen, this other kind of thing can happen. I need to make sure that my system is going to be able to react correctly in this situation that I know already. And we can use logic. We know that this can happen and this can happen. Maybe it means that the combination of those two things can happen as well. So by combining not different kind of knowledge, we can create new scenarios. We can use generative AI to create scenarios. It's very important also to use crashes. So all the accidents that already exist, if we want to be able to demonstrate that we would progress in dealing with situations that currently cause accidents, we of course need to have those accidents represented in the scenarios that we will use for verification and validation. And if we want to be able to have a realistic representation of all the things that happen, we also need to collect data on a large scale on the open road using ground truth systems. So it can be roadside observations, it can be drones, and Adrian will show a lot of examples in his presentation. It can be vehicles driving with a lot of sensors, with cameras, with lidars, and so on, to build a ground truth and be able to entirely model what's going on the road and measure how often things happen. And of course, all this knowledge ends up as well in some standards, in some regulation, in some standardized scenarios that are used to validate not only automated systems, but also driving assistance systems or safety systems. And those can be represented as scenarios. So again, scenarios, they are the common language that allows to aggregate all this knowledge and all these sources of data into one common reference that can be used for validation. And finally, when you have production vehicle on the road, you can also use them. You should monitor the way that the system works in real life, and you should also collect the data from those vehicles if you're able to do so, to create new scenarios if you are able to identify this way that things that you didn't know actually happen on the road. So to summarize, the scenarios, they are the common language that is used to describe what may happen on the road and how often it may happen on the road. They aggregate data and knowledge from many different sources into a consolidated source agnostic representation. So whether it comes from knowledge, whether it comes from AI, whether it comes from direct observation, we should be able to represent them as scenarios. They encode actual observations in a way that is useful for the verification and validation. So they can be used in simulation, they can be used on test track, they can be used to select the circumstances in which we are going to do public road observations. And they can be used to augment the data. Again, maybe we have observed this thing one time and this other thing the other time, but just logic says that those two things may happen together. And we can generate scenarios this way that we haven't even observed. So it looks good overall, but of course there are a lot of challenges. One of them is to be able to describe those circumstances, those driving situations in ways that are practical for many different purposes. It's not easy. First, how do we invent a way to describe scenarios that is applicable to any kind of driving situation? It's not easy. If we have such a description of scenario, we should be able to use it to search for occurrences in datasets made with production vehicle, made with test vehicle, made with ground truth systems, to be able to count how often certain scenarios happen or not. Maybe it's not the same representation that is ideal. We need, of course, to be able to use them in simulation. Again, maybe not the same way to represent them. Another challenge is how do we actually combine and consolidate knowledge in the form of scenarios from such heterogeneous data sources. I showed on the slide before that there are many, many data sources. How do we create something consistent from this? It's not easy. How do we manage a catalog of scenario that is consistent, that is representative of some operational design domain, of some of the domain in which we want a system to work? And how do we manage that? How do we make sure that we're able to make it evolve if we acquire new knowledge? How do we ensure that what we have is representative and covers the complexity of the situations we may meet in a specific country, in a specific kind of environment, for instance? How do we aggregate many different initiatives that were made for slightly different purpose into a common European platform? So there are many, many, many questions. I don't have the time and I don't have the answers either to in any of them fully, but those are all questions that we are trying to address in the SYNERGIES project. With on the right this idea of aggregating initiatives, aggregating databases, being able to query in a central way different scenario catalogs depending on what I intend to validate. So that's the right part, trying to build a federation layer that aggregates all those databases. And on the left part, building all the tools that allow to do this aggregation of many different kinds of knowledge. Again, drones, roadside observation, test vehicle, production vehicles, accident data, and so on, or to be able to aggregate all those different kind of data sources in a consistent way into a scenario database. So those are the things that we are trying to do currently in SYNERGIES.
Clément, thank you so much. I will kind of interrupt you here because we are a bit tight on time, as you know. I had a question for you, and thank you so much for talking about the scenarios, which are challenging but as well vital for, as I said, in CCAM. I'm sure that our audience has questions, so I will skip the question I had for you, and I will actually move to Adrian, who will now talk about scenarios, but from like an industry perspective. So Adrian, please, to you. You have 7 minutes.
Beautiful.
Thank you very much. So I hope you can hear me, and I put my presentation in full screen mode, and then I can start. So good morning, everybody. Thank you for the introduction. My name is Adrian Zlocki. I'm with FKA, and I was asked to give you some insights from the industry perspective, since we are working together with different industry partners, how we use the scenarios that Clément has introduced, and try to turn data into safer roads. As the introduction, as the motivation, as you can see here, this is a scenario that we have captured from a vehicle's perspective. It's a cut-in, and the vehicle in front of us then starts to brake. What I would like to show here with this slide is that we need these scenarios, just as Clément mentioned, for many different purposes in the development process, but especially for testing and for the safety assurance of automated driving. So in order to make safe, that makes sure that the vehicle, an AD vehicle, is really safe, just as Clément mentioned before, we need to somehow prove it, and we can't do it through conventional methods as we have done so in the decades before, because we just need too much of data and all the changes require a restart. So therefore we try to collect scenarios and try to do a scenario-based development and evaluation process. So the key question is how to collect efficiently this real-world data in high quality. And when we get down one more step, we basically need 3 elements for those scenarios. The first element is the scenario description. So this is what we have talked about before, what you have seen in the video. So what happens actually in this scenario and how can we describe this? A lot of research has been done. There are languages, open scenario in order to describe it. There are models for scenarios. This is the first element. The second one, Clément also mentioned, is the scenario relevance. So basically the question, how often does this scenario occur? Is it a cut-in, like we have seen in the video, or is it a rear case, a corner case, an edge case, which do not so much happen on the everyday basis, but nevertheless very important. So this we call scenario relevance. The third pillar is the scenario reference. In order to use a scenario in any kind of test, in order to turn it into a test case, basically, we need to understand how good we need to perform with the AD vehicle in these scenarios, in these tests that we are testing actually. And here we don't want to overspecify, because that, of course, makes everything much more expensive. But we also don't want to underspecify. So we want to really have a minimum of safety. And in the past, in many research activities, we agreed on international level that our reference is the human driver. So basically, we want to be as good and ideally better as the human driver. For that, we need to understand how the human driver behaves. And this is our scenario reference. So you can see these are the 3 pillars. And when we look at different possibilities that we have to collect data, Clément mentioned most of them already, which you see on the left side. You see all these different possibilities have different strengths and weaknesses when we talk about all 3 pillars. So some of those describe scenarios very good, very detailed. Some of them provide a lot of a good of reference, and some provide a lot of relevance. We have artificial scenarios where we can design and describe the scenarios very well, but for artificial scenarios, we don't really have a reference, because this is only a theoretical performance that we perform with driver models, for example. So this is a matrix which you can send up. And of course, the most interesting part is the real uninfluenced traffic. So basically, naturalistic driving, collecting from real road data. Here, we can collect very good description. We can count the relevance very nicely with the frequency of the scenarios which are occurring. And we have human drivers and naturalistic driving data where we have uninfluenced references. How can we do that? Well, we have vehicles on the road which are equipped with sensors today. Here an example. But it's very difficult, especially for us researchers, to get any access to this kind of data. Mainly, this data is owned by the companies which build those kinds of vehicles. And therefore, we don't get really access. We can build up special purpose vehicles in different research activities, which we have done in the past, which we will do in the future. So some kind of level 3, level 4 measurement vehicles, which also may have an AD functionality. But those vehicles, as you can imagine, are really very expensive. And when we use vehicles, we always have the issue of occlusions, and we can only see from the perspective of the vehicle. If we do have a truck or a bus in front of us, we can't see behind that object. We can use infrastructure data like sensors. There we have a couple of sensors. These have also some high costs and also some limitations, some occlusions, but they are also a very nice tool. And as you might know, at a lot of infrastructure elements such as bridges or traffic lights, we already do have these sensors installed. So very interesting source. And finally, we can use drones. So this is something that we are doing and we have introduced some years ago, where we use drones to collect data directly out of the bird's eye perspective. And here I have a small video, which I would like to play, which shows you how this is done from a drone perspective. So basically, we are having this drone here in this case over an intersection, but we can also use different infrastructure. We are classifying the traffic participants, as you can see here, pedestrians, vehicles, different type of vehicles, two-wheelers, and then we can record the trajectories here in yellow for each of these elements. And then we have perfect input data, which we can use here in simulation, where we can calculate distances, calculate interactions between these traffic participants, and use this data really for our development and for our evaluation process up to safety assurance in the end. So when we use this to our scenario, which we initially had, which I've shown, we can extract from this kind of data sets single scenarios. Today, this is done completely automated in order to create a scenario database that Clément has introduced. And here you can see in the video this situation. So basically what you see here on the right side of this bird's eye view is this white vehicle and the dark vehicle, what you see on the video in the left in front of us. Our own ego vehicle is not yet coming into this scene. So we are coming when I play the video from the right side. And here you can see this cut in with the brake on the one side in the video from the vehicle's perspective, and in the bottom side from this drone perspective. And I'm going to play this video here, and you can see here this guy, this white guy here, is now cutting in and then braking in front of us. And this is what you can really extract from the video data. And then you have, of course, a lot of information, like, for example, here, lateral positions, accelerations, heading, distances, and you can analyze the scenario in all beauty. You can collect this kind of scenario for all different elements from all different infrastructures globally, basically. Here are a couple of videos from a roundabout. And on the right side, you see a construction sites from San Francisco, where you actually do have AD vehicles. Here's from India, a scenario with a cow on the road. Oops, sorry, finally, here, I think this is not a video, but this is a San Francisco screenshot with a lot of AD vehicles in there. So you can actually also monitor the behavior of the AD vehicle as an additional ground truth. So this brings me to the end of the presentation. Data is really necessary to understand traffic, to understand how our AD vehicles shall behave in this traffic, to come up with scenarios for validation, for verification, to create even data sets for AI application. Today, AI plays an important role to end systems are being introduced. So we need this kind of data. There are many different data sources available today, which all have strengths and weaknesses, but we can use today all kinds of different data. And in the data, we now try to apply algorithm to find these scenarios, normal scenarios, which you can find on an everyday basis. They are quite easy, but also these corner cases, these edge cases, which are most interesting, which you also need, especially in the simulation, in the beginning of your process, and especially also later on for the safety assurance. And with that, I'm coming to the end. Thank you very much for your attention. Thanks.
Thank you so much, Adrian. Thank you so much also for showing the videos. I think it's really interesting to, pass from the theory data to the real videos. I really like the example of the cow because with Clément, we talked about underrepresented scenario, and that's a good example of it. So it was really interesting. I as well had some questions for you, but as I said, I will sacrifice my time for the audience. And I think now it's better if we move to Riccardo Donà, who is joining us from JRC, European Commission. And we'll talk about the policy side of CCAM, of what we've been discussing so far. So Riccardo, to you, thank you.
Thank you very much, Carmen, for having me today, and thank you for your kind introduction. I will share the screen. And good morning, by the way, to everyone online. Okay, so hopefully you should be seeing my screen and hearing me well. Okay, so as I mentioned, as Carmen has already mentioned, I will okay, it works now. Okay, I will talk about what is the regulatory landscape around CCAM and how data and scenario fit such a regulatory scheme from the perspective of European Commission, so policymaker, and the type approval process. So I will actually start by stating the obvious, which is that scenario and data are fundamental pillars for the whole safety assurance process for an automated driving system. So I will be wearing my EC hat today, and I think this webinar is a good opportunity also to explain to online participants how we as policymakers, we have envisioned scenarios and data to fit the overall type approval process. Now, for those of you who might not be familiar with what this type approval is, basically the final step before vehicles are allowed to enter the market. So at this point in time, manufacturers have already figured out everything, so they are confident enough that their systems are safe. So they will be approaching some type approval authorities, which is independent from manufacturers, so it's normally a government, who will carry out an independent assessment and issue a certificate of compliance, which will then allow vehicles to enter the market. So ultimately, I think that's a very important step because one cannot circumvent type approval to get to the market. So it's really the key to large-scale mass production of CCAM vehicles. Now, for the sake of keeping the time today, I think I would pinpoint you to two main aspects concerning scenario and data, of course. One, of course, scenario is key pillar, and second one is data is both input and output. So concerning scenario, I think it has been mentioned today, but I would also like to clarify once again, scenario-based testing is still a very relevant pillar for the type approval. And different from traditional regulation, it's clear that there are millions or billions of scenarios which should be tested for ADs for a CCAM vehicle, depending on the ODD, so where they are going to operate and the use case. And so it's clear that traditional testing alone, on track testing or real world, is not feasible. So we need to scale up, and to scale up, we need simulation. And that's why in the chart you see on the right on this slide, I'm pointing to simulation as one of the testing environment which will be used during the type approval itself, not only during the development of the system, but during the type approval as a tool to demonstrate the safety of the system. So scenario-based testing and particular simulation, I think they are going to be the key for type approval of vehicles. And also, still on scenarios, Adrian showed a very nice example of a CATIN before. So CATIN is when a vehicle from another lane gets into your lane with a lower speed. So it will force you to brake in order to avoid a rear-end collision. That example leads us to use scenario to derive behavioral competency and verifiable criteria for CCAM. What I mean by that is that this period of expectation around the CCAM system is that they will have to be safer than a careful, competent human driver. And using the data and scenario which are collecting HID or any other data set which are around the world, thanks to FKA for summarizing them, we can derive what is in a concrete manner and a quantifiable manner scenarios that careful, competent human driver can avoid, so that we can also replicate them for a CCAM system and have verifiable criteria that we can either test for track testing or simulation. So scenarios, key pillar, they are there. They're going to stay for a long time. What has changed mainly is where you allocate them. So it's the sheer number of scenario demand for new allocation method and simulation to actually be promoted to the type approval process. Now, coming to the second point is data. And here I would point you to the green box in my chart, which is monitoring and reporting. So mainly the output. So here we have a type approved vehicles, which means they have already shown to be safe, but we are very well aware that those vehicles are going to be updated over the year during their lifetime. Their ODD can potentially be expanded. And in general, the roads out there are quite an open environment where, despite any VMB you might have carried out during the design phase of the vehicle, there are still unknowns. So it is very important that we put this pillar in order to reassure citizens that we are monitoring and require manufacturers to provide us with operational data from their vehicles to make sure that there are no discrepancies between what the type approval has tested and what actually real world vehicles in the real environment are showing up. So finally, before moving on to the next slide, I'm really fond of a saying which states, if you torture data long enough, they will confess everything. So here, the important point is that we need harmonized criteria for reporting data, and something which we work quite a bit at Commission, because data alone, they are nice, but they have to be given context and not just be submitted as a raw data, which they can be interpreted different from different people around the world. Now moving on to my second slide, final slide actually. It would be a good opportunity to sort of explain briefly the regulatory landscape. So for CCAM, here I'm talking on behalf of another working party. So from Luciana mentioned before, the WP1, now this one is WP29, which is still UNECE, but is dealing with basically vehicle harmonization regulation. So far what we have in Europe, we have a regulation for level 4 system where everything which, as I mentioned before in my previous slide, is already featured. So we have there monitoring, reporting, scenario-based testing, using virtual testing as well. We also apply the same methodology for level 2 systems, so assisted driving, because their complexity is not, is quite significant as well. So not much beyond, not much lower than an ADS system, so a true automated driving system. And finally, from next year, I think there will be a huge change in the market, because UNECE is going to issue another regulation, a general regulation for automated driving system, which is going to be globally applicable. So not only Europe, Japan, so contracting parties under type approval regimes, but also US, Australia, Canada. So contracting parties where China as well, where robotaxi is already a reality. So the fact that we were able to harmonize at the global level, I think, is a huge driver for scaling up the mass market introduction of vehicles. And with that, I hand it over to you because I think I'm run out of time. Thank you.
Thank you, indeed. Thank you so much, Riccardo. This really gives an insight of how safety remains at the core of CCAM in Europe. And thank you for sharing the work you're doing. I will give the word to Fadi because we have 10 minutes left, and I would like him to present the crowdsource platform that has been developed in the framework of SYNERGIES. So, Fadi, over to you.
Thank you so much. Can you see my screen, my
Yes, everything.
slides?
Yeah.
Okay, perfect. First off, hello everyone, and thank you very much for attending today's webinar. My name is Fadi. I am a part of the Safe Autonomy Research Group team at University of Warwick. Now, just before going into the details, I just want to take a step back and approach this topic from the first pipelines. Here, I'm going to discuss the scenario generation crowdsourcing platform, Safety Pool Studio, and it's important in the AV ecosystem. So when you think about any verification or validation process of any automated driving system, it fundamentally requires three main components: the scenarios, testing environment, and the safety evidence and argument. So, which is first start by creating the scenario, format the scenario, and store it in a way that can be executed in the environment, and then you can analyze and build your decision based on the results. But here I just would like to focus on the creation stage. In the scenario creation phase, most scenarios are designed, created, and stored in programmatic language, which are only accessible to engineers and for those with technical expertise. However, one of the most important stakeholders in the self-driving ecosystem is the general public, the citizens, who are often excluded from the safety assurance process and the safety conversation. So there is a clear need to democratize the creation of scenarios by engaging every member of the public and the broader ecosystem. That will give them the opportunity to create scenarios in an easy and accessible manner. And this is very important because citizens can observe everyday road behaviors, and they can capture rare and unexpected scenarios that engineers might not see. And it also will increase the diversity of your data sets, of your scenario data, and can enhance the transparency and build public trust, because at the end, the people who are going to use this technology. So this is why we created Safety Pool Studio. It's a public platform that can empower users to ensure the safety of the automated driving self-driving vehicles. You can then create a scenario in Lego-like environment. It's easy to create the scenario, just a drag-drop scenario. You can simulate the scenario, and then you can share your input about any incidents that you have witnessed or any edge case scenarios. And at the end, we can take these scenarios, pass that to engineers by creating a harmonized system when you can convert these scenarios into a language that engineers can use, can analyze in a standards format. I've created a video here to show you the yeah, let me just, I'm going now to run a video of the Safety Pool Studio. Here you can first select if it's right hand or left hand scenario, the environment of the road layout. You can also select any template you want. We have already built a template that you can use, or you can build your scenario from scratch. Recently also we added a new template where you can import map from Google Map, and you can go to your location, search for your location, and put it and import it into the studio. Then here we are, we've chosen T-junction. That's an example of the scenario. So on the bottom, you can have the vehicle, pedestrian, buildings, environment condition. You can change the road layout. On the top right, you can change the language to support different languages, not only the English. You can take screenshot, and at the top, there's an eraser. You can undo anything, any action you do. Here we are creating a simple scenario. that have different vehicles. You can change the speed, also the color of the vehicle to distinguish between different road actors. Can here also place a pedestrian and select the maneuver. Can add more objects and vegetation or weather element, and then you can run the simulation. It really depends. Sometimes you want to encourage the accidents, sometimes you want to avoid the accidents. So here, for example, we can now change the behavior of the vehicles, and yeah, we can remove elements and yeah, change the behavior. Candid. Moreover, you also can change the road layout and the objects and place new stuff. For example, here, if I want to change this T-junction to make it like kind of like a bend road, that's also easy to do it. And it also it verifies the road if there is a bend or edges. Also, it's easy to handle this. So this is an example of what we can do with Studio. That's just a recap of the features that we have in Safety Studio. Finally, this would help by making the citizen an important part of the ecosystem. So we can capture variations of different scenarios which engineers might miss. Also, it helps uncover edge cases. And also convert these scenarios into scenarios that can be running in simulation pipelines, so engineers can get benefits from these scenarios. Finally, please, you can just go and scan scan this code. You can go and try the tool by yourself. When you run the scenario, you can just submit the scenario by clicking on the button submit. And please, here you can input four fields: the scenario name, the country, the region, and the scenario source. So for the scenario name, in order for us to recognize that the scenario is coming from this webinar, please write at the top in the scenario name like SYN Web 3 and then your scenario name, so we know that this scenario is coming from this webinar. That's everything from my end. Thank you.
Yes, thank you so much. And as we said, it's important that citizens are included in the shaping of the scenario. So I wrote the Safety Post Studio link in the chat as well. As Fadi just said, we encourage you to contribute and help us work towards safety of the CCAM. We have 2 minutes left. I am glad to see that you've been asking some questions in the chat. If there are no more questions, I would like to thank the speakers for taking the time to give us these very interesting insights on safety on CCAM. And I will also write in the chat the links to the SYNERGIES project. So I warmly invite you to check the work we are doing. And if you would like to dive in deeper into the topics that were discussed today, you can always reach out to us, and we will make sure that you are put in contact with the speakers that kindly joined us today. So thank you to the speakers. Thank you to the audience for your time. And yeah, stay tuned for the development on the project. Have a great day.